Hi guys, welcome to this page of the notes, and I think what you can see here right away, what we're going to do is we're going to write proofs, but we're going to write proofs using this idea of congruence. Let me show you how this is going to work, but first, before we do these proofs, let me make this distinction. If you're taking just a geometry class, right? If it's geometry, more than likely your teacher is going to give you kind of the bones, sort of the general outline of the proof, and then just have you plug in a couple of the missing pieces. If you're taking an honors geometry class, more than likely your teacher will have you build the proof from scratch. You'll have to put the whole thing together yourself. That's the distinction that I'm gonna make with my geometry versus my honors geometry classes. So depending on which one you're in, we'll talk more about that as we go ahead and do these problems. Let's just jump right into it. We looked at proofs, right? We looked at proofs back in chapter 1, section 4. And the type of proof that we looked at was writing a 2-column proof, which is exactly what I want you to do here. Write a 2-column proof. Now, what do I tell you? Well, here's what I tell you. I tell you that these triangles are congruent. Let's take a look at them. I give you that triangle ABD. That's this one right here, ABD. I tell you that that triangle is congruent to ACD. This one right here. So you're told that those two triangles, the green one and the blue one, you're told that they're congruent. I want you to prove that D, this point right here, point D, is the midpoint of BC, line segment BC. Fantastic, here we go. All right, always in a 2-column proof, right, you're going to have a statement, right, and then a justification, right? So we're gonna write out our statements, right, as we go from what we're given all the way to what we're being asked to prove, but you must justify each step. So here we go. Always start with what you're given. I am given that triangle ABD is congruent to triangle ACD. What allows me to write that statement? Well, it's given. That's my justification. I told you that these two triangles are congruent, so you can write that statement because I gave it to you. It's given. Now what we're trying to do then, right, is we're trying to prove that D is the midpoint. So here's what your next step probably would be. We need to now say something about line segment BC. And here's what I would say. Please notice, BD, line segment BD, plus line segment DC is equal to the entire distance. Do you remember what that is? Look at this. Line segment BD, that's that one, plus line segment DC, that's that one, is equal to line segment BC, right? Equal to the entire length. Do you remember? Do you remember what this is? What is this, right? That is segment addition postulate. So the segment addition postulate postulate allows me to write that step, right? And it's a postulate. It means that we don't have to prove it. It's just common sense, right? It's common sense that if you take BD and add DC, you're going to get a length BC, right? It's a postulate, right? So I can write that statement based on the segment addition postulate, but based on congruence, here's what I can say. I know, right, these are congruent triangles, which means corresponding parts are congruent. Well, BD and DC are congruent corresponding parts. So my next statement would be BD is congruent to DC. How can I write that? Well, it's my definition of congruence. I apologize, I had to squeeze there, right? That's what the definition, I tell you, these two triangles are congruent. If the triangles are congruent, then corresponding parts must be congruent. Well, BD and DC are corresponding parts. That means they must be congruent. This is our definition of congruence. This is the definition of it. All right, well, here's what I know, right? BD plus DC gets me BC. And because the definition of congruence, BD and DC, are congruent. So what do I then know? Well, I know that D must be the midpoint. D is the midpoint of line segment BC. How do I know that? It's the definition of midpoint. Right? The definition of midpoint tells you the midpoint is a point that splits a line segment into two congruent parts, right? If D is the midpoint, then this length and this length have to be the same. That's the definition of midpoint. It's the center point. It's the midpoint. It splits the line segment into two equal parts. Well, I know I have two equal parts. BD is the same as DC. So, by the definition of midpoint, D has to be the midpoint. Now again, if this were an honors geometry class, you would need to be able to come up with that proof on your own, the statements and the justifications. If you're taking a geometry class, what I would do is I would give you this proof and then I would just leave a couple parts out. Like maybe I would leave that part out, right? And then, I don't know, segment addition postula, right? So I would leave that part out, right? Because you should be able, right? Segment addition postula, you should be able to go, BD plus DC is equal to BC, right? So you could write that statement in there, right? And then maybe I put, this part right here, and I would erase this guy right here, right? D is the midpoint of BC. How do I know that? It's the definition of midpoint, right? So I would give you the proof and then just ask you to fill in the missing pieces, right? I got one more for us here. Let's go ahead and practice another time. Let's do this again. Once again, right, we're starting with congruence. I tell you that these two quadrilaterals are congruent, but I give you more than that. Please notice that I also tell you angle J and angle K are congruent. So, J and K are congruent. That's interesting, right? I didn't tell you that one angle in a quadrilateral is congruent to another angle in a different... I don't have to tell you that, right? I told you the quadrilaterals are congruent. Because I told you this, you already know corresponding parts are congruent. What I've given you is an additional piece of information telling you that these two angles are congruent. J and K are the same measure, right? They're the same measure angle. All right, here we go. I want you to prove that angle J, and angle P are congruent. Here we go. Always start with what you're given. So, J, K, L, M is congruent to N, P, Q, and R. Why? It's given. But don't stop there. I then told you angle J is congruent to angle K. Okay, how do you know that? I gave it to you. I told you that they're congruent. So once again, I have another given. Okay, now where do I go from here? Again, keep in mind, I'm trying to prove angle J is congruent to angle P. All right, well, let's think about this for a second. If I were to take these guys, right, I've told you they're congruent. I've told you they're congruent quadrilaterals. So what we should do then is figure out what are the corresponding parts. Well, angle J would be congruent to what angle? I agree. Angle J would be congruent to angle N. Yeah, for sure, angle J would be congruent to angle N. Angle K would be congruent to, if we were to flip it over, K is congruent to P. Wait a second. I'm trying to show angle J is congruent to angle P. Look at this. I know K and P are congruent. So, angle K is congruent to angle P. How do I know that? Corresponding parts. Right? It's my definition of congruence. If I have two congruent figures, corresponding parts must be congruent. K and P are corresponding parts, so they must be congruent. You ready for this last step? Check this out. This is a beautiful, beautiful last step. If J is congruent to K and K is congruent to P, what do I know about J and P? Yeah. Angle J must be congruent to angle P. Do you remember what property that is? It's actually a property from algebra. Do you remember? If J is congruent to K and K is congruent to P, then I can say J is congruent to P. Yeah, that's the transitive property. You'll remember the transitive property this way. We would have written it like this in algebra. If A is equal to B and B is equal to C, then A must be equal to C, right? If A is equal to B and B is equal to C, then A must be equal to C. That's the transitive property. You see, it's the exact same thing. If J is equal to K and K is equal to P, ipso facto, J must be equal to P. Transitive property. Once again, if this is an honors geometry class, I would expect you to be able to write a proof on your own from scratch, giving each statement and a justification for each statement. If this is just a regular geometry class, right, I'll give you most of it and just eliminate a couple of parts, right? Maybe I would get rid of that part. And then I would get rid of that part, right? And ask you to fill in the blank spaces, all right? Guys, thanks so much for joining me for this set of videos. I had a great time looking at congruence with you. Please remember, congruence is a conditional statement. If P, then Q. If two figures are congruent, then corresponding parts must be congruent. And we can use that to solve some really, really awesome problems that not only are geometry, but also involve algebra, which just is amazing. So once again, thank you for joining me. I'll see you guys next time.